Hi, it's Katrina. What if one day the Earth became uninhabitable? What would happen to humanity? Would we build starships and try to find sanctuary on a new planet? Would we move underwater? Maybe we all just bite the dust? Let's check out the options for humanity's last stand after Earth calls it quits. Quick side note, I've been sick this past week, so hopefully my voice isn't too husky, but I guess it's just that time of year.
The other Earths.
Luckily for humans, Earth isn't the only Earth around. There are many Earth-like planets hidden throughout the galaxy that could be home 2.0 in the case of total Earth meltdown. You know, if Earth went full Chernobyl, set off all its volcanoes, and turned the seas into bubbling acid. Or maybe it's our fault, I don't know.
But which other Earth is the best contender for our new home away from home? Could it be Kepler 22b, 2.5 times bigger than Earth? That sounds cozy. Or maybe Gliese 667cc, the planet with a year that lasts 28 days, which means it's Christmas every month.
I'll show you some of the options and then you tell me which planet you like best.
Gliese 667cc, the torchbearer.
Only 22 light years away, basically our solar backyard by galactic standards, Gliese 667cc orbits a cool red sun in a tight 28-day year.
That orbit sounds like a sprint until you realize the star it's tethered to burns lower and redder than ours, allowing this world to stay temperate even at close range. Sick of Earth's annoying seasons? Cold one day, hot the next, sweating, then shivering? Well, come on down to Gliese, where every day is exactly the same temperature. This planet is also really heavy. Weighing in at 4.5 times Earth's mass, Gliese is like that guy you know who hits the gym too much and may have anger issues.
This world is comfortable, but it's also dangerously close to its star, meaning it's often attacked by solar flares. Or solar sledgehammers, I should say, for how hard they hit.
If life did take root there, it's likely subterranean. It's hard to believe any advanced life form could have evolved being berated by so many solar flares.
Humans could theoretically live here if we brought our own shovels.
Kepler 22b.
A better option might be Kepler 22b, the first planet ever spotted in the habitable zone of a sun-like star.
Sitting a cool 600 light-years away, this world is about 2.4 times the size of Earth, large enough that its true nature becomes slippery. Is it rocky like Earth, gassy like Neptune, or covered in a world-spanning ocean that might have more seafood than a Mediterranean market?
Nobody knows, but that's half the fun. Scientists do know that each year is 290 days, so pretty similar to Earth. And its host star burns a little cooler and dimmer, which might be good for our skin.
This is a place where the calendar feels familiar, where the temperature is cozy in a fall sort of way, and where there is a lot to explore. The planet is massive. The only issue is no one knows what's actually on the surface. Creatures? Solid ground?
Astronauts might arrive here only to find there's nowhere to land because the planet doesn't have a floor. It takes the floor as lava game to unprecedented levels.
Kepler 69c, Venus with hope.
Not to worry, there's always Kepler 69c, sitting roughly 2,700 light-years away, so not exactly next door.
This planet carries the dubious honor of being compared to Venus. Its orbit clocks in at 242 days, nearly matching Venus's orbit. But the star Kepler 69c circles is only 80% as luminous as the Sun. And that means, although it seems close enough to its host star to be roasted, it might actually sit in the Goldilocks zone. It could be the perfect place to live. At 1.7 times Earth size, it's firmly in the super-Earth category. Unfortunately, super-Earths are untrustworthy at best.
The planet is so big that scientists don't know if it's solid underfoot or if it's a pressure cooker wrapped in poison gas.
For now, it's a coin toss in orbit. One side offers warm oceans and blue skies, the other a cauldron of noxious clouds and crushed dreams. Although these planets seem to be in a perfect habitable zone, scientists simply cannot say if they'd make good places to live. We need better telescopes. Kepler 186f.
Kepler 186f is just 10% larger than our own planet and parked neatly in the habitable zone of its red dwarf star.
Found 500 light-years from Earth, it orbits so far from its star that it receives only a third of the light Earth gets from the Sun. If plants ever grew there, they wouldn't be green like ours. They'd be more likely black from drinking in every photon like it's their last. The whole planet could have black trees and shrubs desperately trying to photosynthesize.
And scientists suspect it's tidally locked, which means one side basks in eternal light while the other slumbers in unbroken night. Kepler 186f is a world of halves, or maybe of shadows. I'm not sure if it would make a great home, but technically it is habitable. The only issue is that after a generation or so, we might all become vampires.
Kepler 442b.
If Kepler 186f is dark, Kepler 442b is the greenest place in the universe.
At 1,194 light-years away, Kepler 442b made headlines for being one of the best bets for supporting photosynthesis. It's about 33% larger than Earth and finishes its trip around its star every 112 days.
That means the growing season might be fast, the winters fleeting, and the climate mild. It's hard to tell whether Kepler 442b is a lush garden world or just a very nice gravel parking lot, but scientists say it has potential. But not as much potential as the next one.
Kepler 452b.
Announced in 2015 with great fanfare, Kepler 452b was the first near-Earth-sized world found orbiting a truly sun-like star. It is very similar to us, but bigger.
Its host, Kepler 452, is just 10% larger than the Sun, and the planet itself is about 60% wider than Earth. Unlike a lot of the other potentially habitable planets, this one has excellent odds of being solid underfoot.
Its year even lasts 385 days, only 20 more than here on Earth. But there might be a different, more unique issue here.
Kepler 452b is in a star system about 6 billion years old, making it 1.5 billion years older than ours. So Kepler 452b is not just Earth-like, but potentially Earth ahead. The planet had a pretty huge head start on brewing life. If we manage to reach it, our human astronauts might find the ruins of an advanced alien civilization. Because if life evolved there, it had plenty of time to build pyramids, convert them into tombs, reinvent them as spaceports, and then blow themselves up with nukes before humans crawled out of the primordial soup as fish with legs.
As fun as it is to talk about all these potentially habitable planets, humans don't currently have the means to get to any of them. But we will, one day, and I'm going to tell you about how we'll get there right now.
Directions to Proxima b.
So let's say Earth is kaput and we're still looking for a place to live. All of the planets I told you about are great contenders, but I failed to mention the one planet that is actually most likely to be settled first by humanity.
I didn't mention it before because I want to talk about it pretty seriously now. It's a rocky little world called Proxima b, only 4.22 light-years from Earth, a distance that sounds small until you realize it's 25 trillion miles. The planet is circling our closest stellar neighbor, the star Proxima Centauri, and based on what astronomers know, it might be one of the most Earth-like exoplanets ever discovered. I don't even need to describe it because it's practically a carbon copy of our home world.
Obviously, we should try to reach this new planet. In the future, I'm guessing we will. But how are humans going to get there? And when? Once we reach the Moon, then Mars, the next logical step is Proxima b. It's the one world where humans might truly get a fresh start.
Turns out, someone's already working on a plan to send nanoprobes to the planet in an attempt to contact any potentially intelligent life forms. Which, now that I think about it, is maybe a smart idea.
Imagine if humans showed up on a starship only to find the planet conquered by dangerous aliens. Talk about embarrassing, because we'd actually be the aliens.
Send nanoprobes, not astronauts.
In 2016, an initiative called Breakthrough Starshot proposed sending a fleet of wafer-thin space probes to Proxima Centauri, propelled not by rocket fuel, but by a wall of lasers on Earth.
Not the pew-pew kind of lasers that droids shoot at Jedi. These lasers are the kind that can push a tiny light sail at 20% the speed of light. That's 134 million miles per hour, which is fast enough to get to Proxima b in just 20 to 25 years. Compared to every other travel plan, this is the way to go. Scientists are talking about rockets and propulsion and fuel like it's in the 1920s, but lasers are the future, and the future of space travel are light sails, completely free of fossils and faster than rocket fuel. The only problem is the technology doesn't exist yet. It's only theoretical, just like the probes themselves, which are designed to be like spacefaring microchips, ultralight, incredibly fast, and no bigger than a Pringle.
Of course, these chips are a lot more expensive than a can of Pringles.
Each one would be equipped with sensors, a camera, and a communications system compact enough to beam data back to Earth across interstellar space.
Pretty cool, right? And it's all completely autonomous. No humans needed.
Why not just use the big stuff?
Just to drive the point home about how absurdly hard this would be to do with typical rockets, let me tell you about New Horizons.
It was the probe that took 9 years to get to Pluto. If humans sent it to Proxima b, it would need over 54,000 years to reach it. That's longer than the entire history of civilization. And while NASA's Juno probe hit speeds of 165,000 miles per hour by slingshotting around Jupiter, even that would take 17,000 years to get to Proxima b.
In that time, humanity could evolve into something that looks like it belongs on Proxima b.
This is why light sails and lasers are the answer. Breakthrough Starshot's solution is a fleet of tiny probes accelerated by a laser the size of a mountain, which requires the kind of sci-fi tech that's just believable enough to be on the horizon.
Pete Worden, the Breakthrough Prize Foundation's chairman, says that building the full-scale system could cost as much as the Large Hadron Collider, so about $6 to $10 billion. For comparison, that's about 4% of Jeff Bezos' fortune or 3 unmanned rover missions to Mars.
When do we launch the Pringles?
So when does the mission begin? Not yet. Probably not for a while.
Worden and his team are still at the prototype stage, with full deployment likely 2 decades off. Even if everything goes smoothly from the funding to the engineering, the interstellar alignment, the laser licensing, then they won't be launching anything until the late 2040s. Then it's another 20 to 25 years of cruising for the probes to reach the planet. Then 4 more years for the signal from Alpha Centauri to reach Earth. So if you're planning to be around in 2095, mark your calendar for the first postcard from Proxima.
You see the problem with interstellar travel. It takes forever. Between the planning, the launch, the wait, the more waiting, suddenly half a century has gone by. And then once the probes reach the new planet, there's still the issue of getting humans there.
Which is precisely what scientists are working on in the meantime. They're just twiddling their thumbs. Astronomers plan to use the European Southern Observatory and other facilities to gather every pixel of data they can on Proxima b.
That includes trying to detect biosignatures. If it's going to cost $10 billion to mail a chip across space, scientists would at least like to know if there's anyone home between 6 and 12 to sign for it.
But you should keep in mind there are limitations. These probes would be tiny. All they'd really do is float by, collect data, and transmit the data back to Earth.
So basically a Fitbit with a PhD. But hey, I can think of a lot worse ways that governments are spending $10 billion these days. Why not actually do something, for the future of the human race? And now for a quick break, because I wanted to give a big thank you to Miss MJ for the super thanks. It really means a lot, and we wouldn't be here without you. Be sure to subscribe if you haven't already to join the Origins Explained family and check out our membership program.
A year on Mars.
They've been training for the worst-case scenario.
Scientists already know what it's like to live on Mars. If Earth ever becomes inhospitable to the point that we all need to pack up and leave like we just got evicted, Mars is the closest landing pad.
The problem is, Mars kind of sucks. It's radioactive, inhospitable, and pretty drab. And after living in a Martian simulation for a year, the consensus is in. Mars is not a good vacation destination.
On a July weekend in 2024, 4 NASA astronauts stepped out of a red-dusted, 3D-printed habitat where they'd been sealed up like prisoners. There was no rocket launch, and nobody got to enjoy a blue Martian sunset. But they did get to feel what it's like to be isolated in a pod for what must have felt like forever. This was a high-stakes science experiment called CHAPEA, or Crew Health and Performance Exploration Analog. Isolation, rationing, and pretend spacewalks were all these people did for almost 400 days.
All while everyone at Starbucks watched from 100 feet away.
Life on Mars built in Texas. This wasn't a film set or some half-baked reality show. Mars Dune Alpha, as the habitat is called, sits inside NASA's Johnson Space Center in Houston. It's 1,700 square feet of Martian roleplay, designed to mimic life on the red planet in every inconvenient way except the lethal radiation and bone-melting cold. The crew moved in on June 25, 2023, and didn't emerge again until 378 days later on a sunny Saturday. Commander Kelly Haston opened the post-mission press conference with a simple, "Hello." During that long year in the simulation, the team practiced Mars walks, as in they suited up and strolled in simulated Martian dust. They also grew vegetables in their own Martian garden and survived on mostly shelf-stable food, things like granola bars and powdered hope. They maintained the habitat, repaired equipment, and solved problems under communication delays that mimicked the 20-minute lag between Earth and Mars. There was no Netflix, no live texting, and no emergency pizza delivery. Simulating the future. Medical Officer Nathan Jones said the time went by quickly, which either means he's a saint or has repressed the memory of 53 straight weeks of rehydrated lasagna. And you've got to wonder, what was the point? Although it seems like nothing but a sci-fi themed camping trip, this was more of a crash course in sustainable living, both for space and for Earth. The idea behind the simulation was that if humans are going to survive on another planet, they need to know how to live within certain limits. As flight engineer Ross Brockwell put it, we must utilize resources no faster than they can be replenished and produce waste no faster than it can be processed. You know when there's a water warning and everyone is supposed to ration their water, but your neighbor is out at 5 a.m. watering every weed on their property? You can't do that on Mars when resources are finite. This experiment was a way to force people to work within certain parameters. This is something that could be translated to Earth living, because if there ever is a point where Earth becomes hostile to us, humans may find themselves living in controlled mini biomes right here on the planet. Forget living on Mars. Earth could become Mars, and humans could be forced to adapt to a world without water, without atmosphere, and where the radiation is so bad humans are basically walking around inside an active microwave. Mars or bust. Everyone seems to be waiting for humans to get to Mars. Luckily, NASA's working on it. The space agency hasn't sent humans beyond low Earth orbit since Apollo 17 in 1972, but that's about to change. The Artemis 2 mission is preparing to return humans to the moon, which is a vital step toward finally sending a crew to Mars. And when that day comes, what the Chapea team endured for 378 days will help shape how future astronauts survive, not just physically, but mentally and socially during long-duration missions where Earth is a pale blue dot. Missions where your entire world is 4 people and a hydroponic tomato plant named Gerald. Insanity might just be one of the biggest hurdles that humans will have to get over when spending long durations in space. How long would it take before you went completely nuts? The deep frontier. Let's get off the space train for a second and talk about life under the sea. Just don't expect a colorful yellow fish and red lobster to start singing. In 2026, 6 pioneers will boldly go where few have stayed, the bottom of the ocean. In a move that pretty much copies exactly what the Chapea team pulled off in 2023 and 24, this team will test just how feasible an underwater civilization can be. A company called Deep is preparing to launch not upward, but downward. They're going to be sinking a high-tech ocean habitat called Sentinel that could kick off a permanent human presence underwater. And the company is serious. This isn't just a publicity stunt or some bizarre social experiment. It's the next leap, not into the stars, but into the twilight zone of Earth's own alien world below the waves. After all, wouldn't you rather just ditch land and live with SpongeBob and a pineapple under the sea? Welcome to Sentinel, Earth's subaquatic ISS. On November 3, 2026, Deep will deploy 6 trained aquanauts, a name that sounds totally badass, into their modular pressurized Sentinel habitat. It's capable of housing 6 people at depths of up to 656 feet. But there's a catch. It can only hold 6 people for 28 days at a time. Deep's aquanauts will not be doing the whole 1-year treatment that the Chapea team did. They've only got 28 days before their bodies morph into actual mermaids. I'm just kidding, but seriously though, it's long enough to study, explore, and experience the ocean like never before. And it's just short enough to avoid a complete mutiny over who didn't do the dishes as sea madness slowly eats away their minds. Unlike traditional dive operations, where humans can only work at depth for a few minutes due to decompression constraints, the Sentinel habitat will operate like a forward base. And as more come online, each one will allow researchers to live, sleep, eat, and do science without constant shuttle trips to the surface. They'll simply move from one Sentinel to the other without having to worry, from exploding like a tin can in a hydraulic press. Each unit is about half the interior size of a Boeing 777, with private bedrooms, a kitchen, renewable power, onboard bioreactors for waste, and access to the ocean through a moon pool. Okay, I'm sold. A moon pool? Each Sentinel module comes with a hole in the floor that you can step through, and suddenly you're in the sea. You can step out of a trapdoor and into the ocean, where you can, make friends with turtles and build sandcastles with octopuses. It's cozy, it's high-tech, and it's made from the same materials as space rockets. Specifically, a 3D printed steel frame clad in Inconel, which is a military-grade superalloy built to endure hellish pressure, saltwater corrosion, and possibly the occasional curious squid. The way Sentinel is shaping up, it could become the International Space Station but for the ocean. And honestly, I might prefer living in the ocean as opposed to living on Mars. What about you? Sea dweller or spacefarer? Let me know in the comments, and remember to subscribe if you haven't already. Breathing easy at 656 feet. Rob Colley is Deep's head of human performance and a hybrid between an elite diver and a yoga guru. He oversees training for aquanauts. He is currently teaching them how to override their own biology through controlled breath work. This is apparently the first step into turning humans into aquatic creatures. According to Rob, your body has a natural dive reflex that conserves oxygen and redirects blood to your core, letting you hold your breath longer. With proper training, some divers can go 6 to 7 minutes without breathing. The Bajau people of Indonesia, who have genetically adapted to life in the water, can dive to 230 feet for over 13 minutes on a single breath. So, if you're wondering whether humans can become more aquatic, the answer is yes, we already have. The Bajau are practically amphibians at this point. If whales once had legs and walked on land, I think humans can evolve to be a little more watery. Why go underwater? There are undoubtedly those who see the deep mission and say, why? The oceans cover over 70% of Earth's surface and host 90% of known life. Think about those numbers for a second. Land is only 30% of the planet and home to 10% of life. That means the party is underwater. We're up here with elephants and lizards while the crazy stuff is going on in the deep. And I mean really deep. Most of that 90% of life exists in what diver Phil Short calls the blind zone. It's the deep part of the sea where commercial submersibles can't go because it's too shallow, yet at the same time, it's too deep for prolonged diving. In this blind zone, about 600 feet down at the lip of the twilight zone, sunlight fades, colors vanish, and the creatures get weird. This is where humanity's understanding of the ocean hits a brick wall. Even today, much of deep-sea biology comes from dead specimens hauled up in pressure-smashing traps. As Tammy Horton of the National Oceanography Center notes, you can learn a lot from a corpse, but not how it fed, bred, or glowed like a haunted LED. This is why the DEEP project matters. Permanent human access to these depths means real-time study of living ecosystems. And besides, scientists are pretty sure that sea levels are going to rise dramatically in the near future. We might want to start getting cozy in the sea. Plus, we might be able to live in the sea on other planets. We always think about living on land, but other planets' oceans might be the key. Life is most likely to be underwater anyway. So what do you think? Would you like to live in a city underwater or in a space city like in the show The 100? Let me know in the comments. Real-life space cities. Space cities are not about escaping Earth because it's boring. They're about escaping Earth because it might try to kill us, or we might be trying to kill ourselves. Between rising oceans, heating temperatures, falling biodiversity, and political systems that operate like a toddler steering a tank, the planet feels more and more like a roommate who keeps leaving the stove on. So the question isn't, should we leave? It's how do we build a second home before the first one burns down? In comes the idea of space cities, entire orbital habitats where humanity might finally get around to designing a civilization that doesn't implode in its third act. It's a vision as old as science fiction and as urgent as the next ecological report, blending O'Neill cylinders, artificial gravity, lunar mining, and the faint hope that we won't just recreate Houston traffic 240,000 miles up. And if you're thinking, sounds a lot like the 100, you're absolutely right. That show wasn't a drama, it was a warning label. Apogeius, the City of the Stars. In 2019, Olivier Boissard and Pierre Marx proposed a space city that they named Apogeius. Rather than building something the size of Manhattan in the void of space, Apogeius would be a small but formidable orbital habitat for 10,000 people. Basically, humans jammed into a satellite and lounging in Earth's orbit. The entire thing will be constructed at the Earth-Moon L5 Lagrange point, a gravitational sweet spot where you can hang a space station like a mobile over a baby's crib. Materials come from the moon, robots come from Earth, and hopefully no one forgets to bring oxygen. The city itself will be shaped like a triangle because apparently Olivier and Pierre are secretly part of the Illuminati. 3 massive housing modules orbit around a central industrial and agricultural hub, all rotating to simulate gravity. If you ever wanted to live inside a giant space fidget spinner, this is your moment. Each housing wing will include 4 1,200-foot-long spheres, while the central garden ring provides 30 hectares of greenhouse cultivation. That's enough lettuce to feed the population, plus 1 stressed hydroponics technician named Carl. All in all, the project will mass 750,000 tons, or roughly 75 tons per person. That's almost exactly the weight per resident ratio of the International Space Station. What Apogeius proposes is not a utopia, but a survivable, rotating compromise, a foothold for humanity in the deadliest real estate market imaginable. When Earth becomes untenable, humanity might have to figure out how to survive from orbit, separated in their own individual stations. Who the heck is going to maintain these things? The idea of humans living permanently in orbit didn't start with SpaceX or Elon Musk's PowerPoint fantasies. It goes all the way back to Konstantin Tsiolkovsky in 1903. Konstantin suggested using rotation to simulate gravity. In the same breath, he also suggested that humanity's future was in space. A bold statement from a man who had never seen a rocket that could leave the stratosphere. Werner von Braun gave the dream a sleek aluminum makeover in the 1950s with his orbital wheel station, which few realize was used by Kubrick in the film 2001: A Space Odyssey. Kubrick turned von Braun's idea for a rotating space station into a place where you could sip cocktails while hurtling 17,000 miles per hour around Earth. The orbital wheel station was never built, but it was improved upon. In the 1970s, a man named Gerard O'Neill took the idea for an orbital station and made it into a rotating paradise. His final design, known today as the O'Neill cylinder, was a tube around 15 miles long. That made it large enough to have its own mini weather system. Still, no such station has ever been built. Designers run into the same problem every single time it comes up. The biggest challenge is simply getting the materials from Earth into space to build it. For now. The 100, when a space city forgets. If all of this sounds speculative, consider The 100, that CW show where everyone is beautiful, morally conflicted, and constantly shouting in forests. The first season begins in orbit. Earth's surface is radioactive toast, and the remnants of humanity cling to a space station called the Ark. Their space station was cobbled together from pre-apocalypse satellites and stations, which means it runs on duct tape. 3 generations were born in the Ark, raised in cramped metal corridors, breathing filtered air, and getting ejected into space for minor infractions. The parallels with Apogeius are obvious, but Apogeius is real life. And where Apogeius is a vision of planned sustainability, the Ark is a cautionary tale. Overcrowded, undermaintained, and governed by a brittle elite clinging to control, the 100 shows what happens when you bring Earth's problems into orbit without rethinking the rules. An artificial home. Putting aside all the fantasy elements, the central problem with space cities is simple. We're used to Earth doing everything for us. Gravity, built in. Radiation shielding, atmosphere. food and water, done. Even with our current problems, Earth still makes life feel like coasting downhill with training wheels and snacks. A space city, by contrast, is a mechanical coffin with good lighting. You have to simulate everything: gravity via rotation, oxygen via filtration, food via hydroponics, civilization with rules that don't collapse under pressure. And here's the brutal irony: people haven't even figured out how to make sustainable cities on Earth. How are they going to do it in space? What makes us think we'll crack the code inside a tin can with lettuce walls and zero room for error when no one's managed to do it on the surface? What happens when everyone in Pod A starts to get a little hostile to folks in Pod B? Humans are often terrible, and sticking them in a metal box in space is a recipe for disaster. But we all persist in dreaming, because space cities, for all their costs and compromises, offer something that planetary colonies do not. They give us a first-class seat in the cosmos. If Earth ended tomorrow and you could choose one option from today's video to save humanity, which would it be? Underwater cities? Space cities? Colony on another world? Let me know in the comments, and thanks for watching! Be sure to subscribe, and I'll see you soon. Bye!